All right, so what we're going to be looking at now is section 2.5, which is going to be linear functions. So when we look at linear functions, they're going to be of the form f of x equals mx plus b, which you might be used to seeing this as y equals mx plus b. They're the same thing. Now, before we get started on finding these things, let's define a couple of the key variables. First, we're going to define what m is. So what m is that is the slope, which you might have heard as rise over run. This is also considered a rate, or you can name this as rate of change. And as well, if we're given 2 points, we can find the slope by subtracting f of x2 minus f of x1 divided by x2 minus x1, which you've probably seen before, and as we know, f of x2, that's the same as y2, f of x1, that's the same as y1, divided by x2 minus x1. Now, what b is that is going to be the y-intercept. So, if we look at a graph, right here where it hits the y-axis is the y-intercept. This always occurs when x equals 0, and it's always going to correspond to the point 0, comma b, which would also be 0, comma f of 0, since f of 0 is what we would get if we plugged 0 into our function. One more thing that we can consider the y-intercept is our initial or starting point, since it happens when we start at 0. Alright, so now that we've introduced what a linear function is, there's just one more thing I wanted to say about that before we start getting on to examples. So when we look at the slope, we're going to have two different choices for slope. We're either going to have a increasing slope, which is positive, that is when m is greater than 0, or a decreasing slope, so that is going to be when m is less than 0 or negative. Alright, let's go ahead and look at some examples now. So when we look at some examples, the first one we're going to look at is if you're given a graph, how do you determine what the equation of the line is? So let's go ahead and just draw a quick graph right here. So let's have the y-axis and the x-axis. So x and y, which we also call f of x. And let's say that we have a straight line, and let's put a couple points on this line. So let's say that we have the point 3, 5, and let's also say that we have the point 6, 1. Now let's say that we want to find the equation for this line, so we have to find the slope and the y-intercept. So this point right here is going to be the y-intercept. It's going to be 0 something, so we have to figure out what that something is. We also have to find the slope. So just by looking at this, I can do a rise over run to find the slope. So here's what rise over run is. To get from this point to this point, I would have to go, let's see, 3 down. So since I'm going down, that would be a -3. Or I'm sorry, it would be 4 down. So it'd be a -4. And I'd have to go 3 over. So slope in this case would be rise, which is how far I have to go up or down, which would be -4, over run, which is how far over I go, which would be 3. Now I know what the slope is. Let's see if I can figure out what the y-intercept is. So so far I know that y equals negative 4/3 times x plus b. Now here's the neat thing, is that this equation will work with any y or x that I plug in that's on this line. So let's go ahead and pick this point to plug in for my x and my y. So my y is 1 equals negative 4/3 times my x is 6 plus b, and that's going to give me 1 equals, let's see, 3 and 6 cancel out to give me 2, so it'll give me negative 8 plus b, which means b will equal 9. Therefore, the equation of this line, and my final answer, is going to be y equals negative 4/3 x plus 9. So the y-intercept I was looking for occurs at 9. If you want to, go ahead and pause the video and try plugging in this other point where we have 5 for our y and 3 for our x, and you'll actually see that you get the same y-intercept no matter what. Alright, let's look at another example where maybe we don't have a picture but we just have 2 points. So, in this example, let's say that we have the points -3, -4, and 5/36. And we want to find the equation that passes through these points. So we want to find the equation y equals mx plus b. So whenever you have a problem like this, the first thing you want to do is find the slope. So the slope, which is m, is going to be your y's minus your x's. So that's going to be 36 minus -4 divided by 5 minus -3, which is going to give me 40 divided by 8, which gives me a positive slope of 5. Now what we're going to do is use this to find b. So far, we know y equals 5x plus b. Now, just like last time, you can choose any point to plug in for your x and your y to find b. So let's go ahead and plug this point in. So we're going to have 36 for y equals 5 times 5, which is our x, plus b. That's going to give us 36 equals 25 plus b, which means that b will equal 11. This means that our final answer is y equals 5x plus 11. Now, let's say after we find the answer, what we would like to do is we would like to draw a graph just using the formula y equals mx plus b. So here's how we can do that. First, I'm going to erase this just a little bit. Alright, I think that's good enough. So if we want to draw a graph of what this function would look like, well, we're going to have our x-axis, and then we're going to put our y-axis on there. So we know that we're going to hit 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We're going to hit the y-axis at 11. That's our y-intercept. And we're also going to have a rise overrun of 5. So what that means is we can either go down 5, 1, 2, 3, 4, 5, and then over 1, or you can go up 5 and over 1 in this direction, as long as the line has a slope in the positive direction.